Welcome to using if statements with numbers. Integers, whole numbers. Welcome to using if statements with numbers. Integers, whole numbers. You can use if statements with integers to compare values. The double equal sign is used to check if two values are equal. Here, we see the double equals operator. It tests whether two values are the same. This is fundamental in decision-making within your code. The input function always returns a string. To treat the input as a whole number, you must convert it to an integer using the int function. This conversion is known as typecasting. In this example, the code asks the user to guess a number between 1 and 5. The input is converted to an integer, allowing us to compare it with the correct answer. If the guess is correct, the program prints correct. Otherwise, it informs the user that the guess was incorrect. When the code runs and the user enters the number 3, the output is correct. This demonstrates how input, typecasting, and conditional statements work together to check user answers. Comparison operators. Comparison operators are used to compare two values, producing a result of either true or false. They are commonly applied in if statements to help programs make decisions. The double equals sign checks if two values are equal. For example, if x is 5 and y is 10, x double equals y returns false, as they are not the same. The exclamation mark and equal sign together check if two values are not equal. In this case, x not equals y gives true, because 5 is not the same as 10. The greater than symbol tests whether one value is larger than another. Here, y greater than x returns true, since 10 is greater than 5. The less than symbol checks if one value is smaller than another. For x less than y, we get true, because 5 is less than 10. The greater than or equal to operator combines both checks. For example, I greater than or equal to 10 gives true, as y is exactly 10. The less than or equal to operator works similarly. X less than or equal to 5 returns true, as x is equal to 5. Comparing values using comparison operators. You can use if statements with integers to check whether a value falls within a specific range by using comparison operators. These operators allow you to test if a number is greater than, less than, or equal to another number. In this example, the code asks for your age, then uses a series of if, elif, and else statements to determine which age group you belong to. If your age is 18 or older, it prints that you are an adult. If your age is at least 13, but less than 18, it lets you know you are a teenager. For any younger age, it prints that you are a child. If you enter 16 as your age, the program responds with, "You are a teenager." Using floats, numbers with decimals. You can use if statements with float numbers to check decimal values. Floats are numbers with a fractional part, and you can compare them just like integers. It's important to remember that the input function always returns a string. To perform numeric comparisons, you need to convert the input to a float. The input function allows us to receive data from the user. However, by default, this input is treated as a string. Here, we convert the user's input to a float using the float function. This is essential for comparing numerical values, especially when dealing with decimals. The code checks the temperature entered by the user. If the temperature is greater than or equal to 20 degrees Celsius, it prints "it's warm." If the value is at least 10 degrees but less than 20, it prints, "It's a bit chilly." For anything lower, it prints, "It's cold." This demonstrates how we can use if, elif, and else statements to make decisions based on floating point values. In this example, entering 22.5 as the temperature produces the output, "It's warm." This confirms that the condition for temperatures of 20 and above is met, and the correct message is displayed. The split method allows you to take a single string and break it into a list of smaller strings, using a separator, by default, a space. This is useful when you want to extract several pieces of information from one line of input. In this code, we ask the user to enter their full name. We then use the split method to divide the input into separate words, storing these in a list called name parts. Finally, we print out the first and last names separately by accessing the first and second items in the list. Here's what happens when we run the code. If you enter Alice Smith, the program displays first name, Alice, last name, Smith. This shows how Split can help you handle and organize user input by breaking it into meaningful parts.